All right, let's just dive right in, shall we? Today, we're taking a journey into the very fabric of reality itself. We're going to be exploring the fundamental nature of time and space. So, get ready.
And we're going to kick things off with a question that, it sounds pretty simple on the surface, but it underpins literally everything we experience. Is this present moment, this feeling of now, actually real, or is it just some kind of stubborn illusion our brains create?
To even start to answer that, we have to deconstruct the way we perceive time itself. This neat little package of a past, a present, and a future. What this quote is getting at is this idea from Einstein's relativity called the block universe. Imagine that the past, the present, and the future, they all exist simultaneously. They're all out there, like individual frames on a giant reel of film. Our consciousness is just moving through those frames, one by one, giving us the feeling of time passing. But if you could step back and see the entire film at once, the whole thing from start to finish, the concept of now would just disappear. This idea of time as a fixed dimension, it actually leads us to a really similar, really old debate about the nature of space. The core question is pretty simple. Is space a thing all by itself, or is it only defined by the objects that are in it? So in one corner, you've got Isaac Newton. He argued that space is basically a giant empty box that contains the whole universe. But in the other corner, you have Gottfried Leibniz, and he claims space doesn't exist on its own at all. It's just the network of relationships and distances between objects. For him, if you took away all the objects, poof, you'd take away space itself. And Newton's view, this idea of an absolute, unchanging stage for the universe to play out on, that was the dominant idea in science for centuries. And it makes sense, right? It's intuitive. A fixed, invisible grid where everything happens. But modern cosmology has thrown a huge wrench into both of these classical ideas.
Because our current understanding suggests something far, far stranger than either an empty container or a simple relationship. It suggests that space is this active, dynamic thing that is literally being created out of nothing. We all know this fact. It's one of the first things you learn about cosmology. We see distant galaxies rushing away from us. But the implications of this simple fact are, well, they're truly mind-bending.
And this is the critical question. This is the one that trips everybody up. If the universe is getting bigger, what's outside of it? Is it just expanding into some bigger, pre-existing void? Well, according to our best models, the answer is no. See, the expansion of the universe isn't really about galaxies flying through space. It's about the continuous creation of more space between them. The vacuum of space-time is constantly coming into existence everywhere all at once. But here's the problem. This process, it appears to break one of the most secret laws of physics, the conservation of energy. As space expands, the energy from things like light just gets stretched out and effectively vanishes instead of just moving somewhere else. The creation of space, it seems, plays by a set of rules we don't fully understand yet.
We all know the cosmic speed limit, right? The speed of light. Nothing with mass can reach it, and it's supposed to be the absolute fastest that any information can travel through space. Or is it?
Here's the crazy twist. While objects in space have to obey the speed limit, space-time itself has no such restriction. The very fabric of the universe can, and in some cases does, expand faster than the speed of light. And this brings us all the way back to time. These paradoxes of space, being created from nothing, expanding faster than light, they lead us into even wilder speculations about the true nature of time itself. So this raises a really deep contradiction. According to relativity, time completely stops at the speed of light. A photon traveling across the universe experiences no time at all. So if our now was moving at light speed through that block universe we talked about, we shouldn't experience time passing either. And yet, we do. This suggests our now has to be moving differently. To try and solve this, some physicists speculate that time itself might be superluminal. In other words, it travels faster than light. And they point to other things that might behave this way, like gravity. Some theories suggest gravity has to act faster than light for entire galaxies to hold their shape across such enormous distances. And here's where it gets truly strange. According to the bizarre rules of relativity, anything that could move faster than light would also appear to be moving backward in time. So if time itself is superluminal, it could mean it doesn't just flow forward into the future, but also backward into the past. And that That leaves us with a final, profound question to just think about. If time is not a simple one-way arrow, but this complex flow moving in both directions, does that mean the future can influence the past? Does it mean that on some deep, fundamental level, you have already been here, listening to these very words?